Okay, let's start this optional review and demonstration for Lab 1 and Module 2. I'll have some slides that you'll be able to follow along with, but also I'll do some demonstration in Excel for those that want to open the workbook from this lab and follow along a little bit. And obviously you can control pause and keep your solver or your Excel spreadsheet work in line with what I've most recently done. I will not do the full set of lab things. This is supposed to be complementary to the handout, but I'll do most of what you need to see to be able to get through the lab. Again, this is optional to complete this video, just want to say before we start, because if you feel comfortable working through just the handout and the steps required in answering the questions, that's the way you should do it. Okay, so our objectives, though, just to get some solver basics out of the way. I'm sure we have people in this class familiar with using solver, but we all I have to make sure everyone's at the same place before we start using it in more detail. And also maybe this lab is designed to get you all the prep necessary to do part A of the assignment. Materials, there's a worksheet in the spreadsheet, the workbook for this module. It's called Lab 1, I believe, and that would be necessary. And the lab handout has all of the detail, and it should be considered required reading for this lab. And then this video demonstration. We'll cover a few topics. I will show again how to install solver. That was part of our lecture series this time, but I'll show it again here. We'll review how to set up equations and inequalities in Excel, which was really something we covered in Module 1, and then show how to implement a solution. Once we have all those equations together and inequalities, how do we put it into solver? And that includes setting the objective, declaring our variables, declaring constraints, and then choosing an algorithm. Okay, so in the handout, the first thing that's mentioned is you need solver, okay? And Microsoft, just some background, Microsoft does not, as I understand it, own solver. They license it. So some other sort of software engineer or firm, at least originally, produced the solver package. It was good, robust. So many people were using it that Microsoft licensed it and maintained solver with updates, right? So if a new version of Excel comes out, they work with the licensor to make it. Now, I don't know if that's still the case. It certainly was when I was a student and when I first started teaching here at Purdue, because the solver bugs would start showing up anytime we get a new version of Excel, and but those bugs would be fixed. But anyway, because of that sort of add-in or optional relationship, it's not a sort of true Microsoft product. Solver's always been this add-in, and if you do a normal installation of Excel, like most of you would do, or an Office installation, and pick customary or normal installation without going through and doing some kind of custom choice, set of custom choices on what's going to be installed, then you probably don't have Excel. So let me switch over to my spreadsheet and show you how you would install solver. Okay, so if I go at the top of my spreadsheet to this location that says data, and I click on data, then that changes the ribbon, I think that's what they call this, to the data ribbon, and all the way over here to the right, under analysis, it says solver. I also have another one for data analysis. Some of you may have a version of Excel, I believe maybe the Office 365 package calls this Analyze. Either way, it's usually settled all the way to the right here, and it's always found on this data ribbon. But if you didn't see that, if you didn't even have this analysis or analyze over here, we would need to find a way to get that in there. And for everyone, it should be the same. You click on File up here in the menu, go all the way to the bottom, and you'll see Options. And so even though Solver wasn't installed, it was there, right? So as part of the regular Office installation, it was there. You don't have to go and find the disks. It just wasn't sort of activated. Is the key thing. It wasn't. The installation piece is still sitting there, but it's not been installed yet. So anyway, where we find it, you can go to add-ins. That's what it's called. And so you'll see here all kinds of things. So I believe it looks like I have PDF Maker installed to work with Excel. And then I have Analysis Tool Pack, and then the Visual Basic add-on to these. And so these are all sort of libraries. And then the Solver add-on. So if you had it, you could click there. And in yours, it wouldn't be in the active, it would be in the inactive application add-on. So you would find it down here. If you don't have it installed, you could click on it and proceed to install it, or you could come down here to where it says Manage Excel Add-ins and click on Go, and then you should get this box. And this will tell you which ones are available to be added in. It means they're already on your computer, they're just not installed yet. And so you can see I have Solver add-in, Analysis Toolpack, Analysis Toolpack VBA. These two, if you don't have them, especially the first one, maybe you want to go ahead and check that one too. If you're adding Solver, click on this one, because we will use it as well. And it's where you do regression. So it's the sort of regression tool pack in Excel. So later on, when we start thinking about distributions, one of the things we'll do is estimate a linear equation and work from that to do some simulation. So you could click on OK there, and the installation should start. I'm not going to click it because I'm not changing anything. I'm just going to back my way out and go back to my slideshow. Okay, so let's look at our problem in this lab. So just to review, we have maximization of some set of returns, P, being measured here. I think it's called gross margin in the notes over here to the side. Corn is one activity, beans or soybeans is the other activity. The activity unit is an acre. Okay, so when C becomes 1, when we set this value to 1, we're saying I'm planting, maintaining, harvesting, and marketing an acre's worth of corn. Same thing here for B. I'm doing all those activities all the way to market. Give me the total net return for selling an acre's worth of beans, right? And so that's what the activities are measuring here. And if this is 10 and this is 5, then I have twice as many acres worth of soybeans in the setup. The land constraint here is measured in those units. So every time you plant an acre of corn, it sort of uses one of the 320. You plant an acre of beans, it uses one of the 320. Moving down here to the cash constraint, every time I plant an acre of corn, my available cash on hand for putting out the crop, right, for putting it out, maintaining it, dealing with any transportation that requires cash payment. Think of this as sort of a credit line or a cash on hand, right, because it is bounded at 20,000. Every time I use or decide to plant to market an acre's worth of corn, I'm going to use up $50 of my available cash. For soybeans, that'll be $100 per acre. And then down here in storage, so every unit of storage, every acre of corn I plant is going to use up 100 units of storage, measured on the right hand side here. And so you can see from this that corn uses storage at a high rate, it uses cash at a relatively low rate, right? So by comparing corn to beans, our only two options, you get an idea of what's expensive in terms of my cash on hand constraint, what's expensive in terms of my storage constraint. And I think anyone who's dealt with storage realizes this is probably measured in bushels or some kind of volume units on the right hand side here. and so that an acre of beans has a lower volume or yield in terms of bushels of soybeans versus corn, right? So that's the sort of cost measure here, is in how much storage is available and which activity is using it at a higher rate. And then, of course, the land constraint, an acre of land to be planted is just an acre of land to be planted. So they use up land at the same rate. Yeah, so let's just go ahead and anticipate a little bit of what Quiz 4 is focused on. It's actually what I was just talking about. It's really, Quiz 4, the lab requires you to go through and solve all of this and go through all the steps in Solver, and we'll demonstrate those. But the quiz questions in Lab 4 really go with both this setup and the first reading from the Anderson et al. Chapter. Right? So as you read through that and read about model setup, one of the things they focus on is sort of what are the units in the constraint equation, and so this lab is sort of a check on your reading as well as on looking at this model in Excel. Okay, so and units become a big issue, right? So each equation, anytime you write an equation for sort of a real world quantity, it's in some kind of units. And just like we would say, an equation, the right hand side, the left hand side, both sides of an equation need to hold with truth, right? The value on the left hand side, the value on the right hand side have to be the same. That's what the equality sign means. Well, the units had better match up as well. Okay, so if one side of the equation has variables in different units than the other side, then that's what we need coefficients for. That's what we need conversion factors for. Okay, and so let's talk through our model just a little bit. Starting from the profit equation and the returns equation up here, this left-hand side is either measuring gross margin or profits. I'm going to use those terms interchangeably, but it's sort of dollars of return, right? It's the thing I want. So this dollars of return, and on the right-hand side, if the left-hand side is measured in dollars of return, then an evaluation of everything on the right-hand side had better also be the dollars of return, the dollars of gross margin, dollars of profit. So the right-hand side, if you look in the spreadsheet, it's on the right-hand side. The right-hand side objective variable in the spreadsheet, so when I say right-hand side, I mean it's over to the right here. This objective cell says it's measuring total profit, gross margin, either way, but this profit measure here is in its own units. And those units would be dollars of profit, dollars of earnings that I get. The left-hand side activities, if you move down here to a picture of the spreadsheet, we know that the corn activity is measured in acres. Acres that I decide to plant, maintain, harvest, market of corn, right? So it's a lot of activity boiled up into this name of corn, but it's measured in acres. So what must be happening is whatever coefficient we use to multiply this variable corn is converting it into a measure of profits. When you do, or when you choose to initiate this activity corn, you do all the work, right? You plant, harvest, maintain, harvest, store, and then eventually market. Well, you're measuring it in terms of acres, but you're also converting it into some other things. But when you go to the market and sell it, what does it mean to you? Well, that acre of corn needs a translation that tells me what it's worth on the market in terms of my profit. And that's where the $60 comes in. That's the translation that's being done. So the left-hand side activities being measured in acres of a crop means that we need a coefficient that multiplies those activity levels, and that coefficient must have these units. That coefficient must be a translator, or a converter, that takes the activity level units of an acre and converts those into dollars of profit. And so that unit would be dollars of profit per acre of activity level. And that's what those coefficients are. In other words, the coefficient in any equation is this translator or converter, converts the variable units from one type to some other type that we can use to be measuring things. If you look at the constraints, you get the same result. The activity is going to be the acre of the crop. If we call that right-hand side for the storage constraint bushels or volume of storage, then the coefficients really should be the yield, or the number of bushels that you take away from an acre of the crop. And so let's look at it. You decide to make 1 acre of the corn crop. The storage requirement is 100, and so if this right-hand side is measuring the total bushels or the total volume available, then this number tells us every time I plant 1 acre of corn, how many of the units that we're talking about in this storage constraint is that generating. And so if it's 100 bushels of corn that you take off of that acre, then that's the conversion factor. Okay. So that's really what the quiz is about, making you think through the setup of this model. This is what the model looks like, and in fact this one's given to you entirely, the setup in Excel. When you get to the assignment, you actually have to go in and fill in all the values. So, but we use formulas. Let's just remember, I'll open the spreadsheet here in a second and we'll talk through it, but remember from Module 1, we use formulas in Excel. You know, a cell multiplied by another cell added to something else is a formula in Excel, and that's how we implement equations in Excel. Okay, we just pick a cell and we say that is going to be a formula, and it's going to hold the value of some variable. In this case, this cell right here is going to hold the value of the objective variable. And then when we do constraints, we have this sort of fixed right-hand side value, this upper limit or some kind of limit that's been described to us. The left-hand side needs a place to be evaluated as well. And so we just name that the left-hand side. Tell me, right, keep track of me in this, for me, in this cell of every time I plant an acre of corn, I'm using up 1 acre of corn, and keep track of it here. So that if I decide to plant 100 acres of corn and 200 acres of soybean, 200 times 1 is 200, plus 100 times 1 is 100. We would expect to see a 300 there, and then we could use that left-hand side versus right-hand side comparison. So remember though that Excel is not using this column. Even though we put the signs in, that's just documentation for us. Excel won't see it. It's just going to calculate left-hand side versus right-hand side. And so that means in Solver, we're going to have to come up with a way to either use this column, which we're not going to do, or Solver's going to have a way to implement comparisons of left-hand side versus right-hand side. And so let's just look at that's what goes on when we implement the model for solution via this Solver process. So we have 4 steps that are required. Setting the objective cell, declaring variable cells that Solver is allowed to adjust, declaring constraints, those are the left-hand side versus right-hand side comparisons that get checked for feasibility, and then choosing the algorithm. Once we do all those things, we'll hit OK or we'll click Solve, and Excel will run it, and I think now is our chance to do that. Okay, I'm now in my spreadsheet. You'll see that I have formulas in all of these, so I'll try to remember to click on them so they show up bigger on the video. There's one place though where the video is going to show you this small dialog box in Excel, and you're either going to have to zoom into your video or just kind of trust what I'm saying as you go along, or follow along in your own spreadsheet so that you can see it better. There's just no good way for me to keep resizing the video as I go, and our experiments with cropping video has not been great. It tends to distort and sort of wreck the encode when I've tried that. But here we see you see that Excel gives you a nice view of what you have as a formula. It says it's the sum product formula, which we did in Module 1, and then B4 and C4 are the blue, right? The blue items highlighted in blue over here, the red items highlighted in red over here. And so what it is take the things in B, multiply 0 times 60, add to that 0 times 90. That's the sum product formula. The left-hand side formulas follow the same sort of picture. This blue multiplied by this red. So every time, these are the coefficients that translate the activity level to the appropriate units here, right? So we're converting acres of corn and soybeans via these coefficients into profit measure. Down here in this column, we're translating acres of corn and soybean into their usage of cash so that we can compare to the limit on this right hand side of cash available. Same thing here. Acres of corn, acres of soybean. The right hand side, I guess the spreadsheet is covering that, but the right hand side, bushels of storage. These are the conversion factors. An acre converts to storage via this 100 coefficient. So we'll do the multiplication and capture the values here. Okay, module 1, we did all this sort of different things where we said, what about a candidate solution of 120 and 200 or something like that? Let's check. We know that meets the acreage constraint, but it violates this constraint here, and it violates this constraint, so that one doesn't work. So maybe we go back and make some changes or whatever, and that's all fun. Or I mean, I don't know if it's fun, but for this class it qualifies probably. But we have a better way. We have a tool that we can use, and so we'll implement that now with Solver. So I click on Solver, and you can see that mine is already set up. Maybe yours will be too. I don't know what the spreadsheet you're going to use looks like. I mean, if it isn't, you'll follow along here, or follow along in the handout. So here it says, the first part of this says, point me to the cell that contains your objective variable. And so it's D4 right here, and it's already been selected as D4. And I could click on this red arrow and get this field that says solver parameters. And by clicking on that cell, it will change the cell reference to D4, and you get the right value. The next thing we're going to do is give Solver instructions on whether to maximize or minimize, and so I've clicked on maximize. You can see it's just a radio button, I think is what they call these, and so that one needs to be clicked. And then the next one is where we declare the variable cells, or here it says changing variable cells. And so this is the same thing. It's a field ready to take cell references from the spreadsheet. So we click on the red, and I can just highlight cells B3 and C3, and that's what the solver takes as the input. When you click on this, those get added in as the changing variable cells. And then I'll go ahead and delete all the constraints so you can watch me enter those. And so the next field is declaration of the constraints, and so this is where we use our setup for left hand side and right hand side. And so I'll start adding the constraints by clicking the button that says add, and so you can see here it's looking for a cell reference for the left hand side, and then it's looking for this limit for the right hand side, or the constraint value. And then in the center it has some options. It has a drop down that says less than or equal to, an equal sign, a greater than or equal to sign, and then we have some other ones. This one's for integer, and this one's for binary. But for right now, less than or equal is what we want to use, so we'll keep that. And then I'm going to put the cell reference on the left hand side of D7. On the right hand side, I'm going to put F7. And then that's only my first constraint, so I'm going to click add to get a second one. We'll go with the D8 less than or equal to F8 and click add one more time. Now we'll have D9 less than or equal to, so that sign stays where it is. And then the right hand side and F9. And when I get to my last constraint, I can just click OK, and you'll see that all three constraints have been added. Okay, so we've declared all of our constraints, or have we? Right? Well, remember, we need non-negativity constraints, and in fact that's what happens right here. So up here we declared the variables to be B3 and C3, and down here Excel knows, or Solver knows, that it's going to have variables, and it also knows that it's very likely in many problems that you want those variables to be non-negative. Okay? And so we don't have any direct constraints on these variables yet, but if we just click this checkbox right here, it will add for us automatically the constraint that says corn acres can be 0 or positive but not negative. And at the same time, it will take the soybeans activity level and let it be 0 or positive but not negative. And so this line right here, this checkbox, is the equivalent of writing 2 more constraints that force the activity level for corn and soybeans to be positive or 0, which is another way of saying non-negative. The last thing we need, the solving method or the algorithm choice. We're going to use simplex LP every time unless I tell you something different, because that's the classic linear programming solver. You'll see it has two other alternatives here. One is GRG nonlinear. That's for a nonlinear model. We used that already in this module. In lecture 1, I showed you how to solve a nonlinear model. Evolutionary solvers are a little different. They are, so if GRG nonlinear is really this, I think it's a GRAG sort of approximation to the calculus solution for the problem. Evolutionary solvers think like evolution, right? They think about mutations. And so these are for very difficult problems that may have large flat spots in the objective, or like hills that go up and then down and then up again. And so evolutionary solvers are to try to find really difficult solutions to problems where a normal sort of tracking solver would say, okay, I keep trying to improve this and I can't, using these sort of small increments. Well, evolutionary solvers introduce at regular intervals what they call mutations that cause the solver to move away from its current location and try to solve the problem again from some other location, and that is a very cool thing, but not something we'll encounter much in this class, so, or have much reason to. So we'll use simplex LP for our linear programming, and the value there is 1, it's efficient, and 2, it comes with some really nice sensitivity built in that we'll make use of. Okay, so once I've chosen simplex LP, I'll click on solve. And if you complete that, you'll get something that looks like this. I have 2 monitors running in the on my machine here, and only one of them is being captured, so that's why you didn't see this till I drug it over here. It says solver found a solution, all constraints and optimality conditions are satisfied, and it gives you the option here to keep solver solution or restore original values. I'm going to keep the solver solution. And then over here it offers you some reports, an answer report, a sensitivity report, and a limits report. We're not going to do any of those right now. We are still in the early phase here where we want to do the analysis on our own. We want to play this out and look at everything and see what we can learn from that. I mean, you're welcome to click on these. What you do is you just click and highlight the ones you want, and they open in new sheets. But that will be our module 3 topic, will be to delve into those with great detail. So I've got this ready. I just click on OK, and my spreadsheet is updated to what I have. Okay, so let's get back into the PowerPoint just for a second. We finished solving, and let's look at the solution. So let's remember what the components of a solution are. The objective cell value, or the profit, right? Whatever we were trying to maximize, we need to look at that. What are the levels of the different activities? And then the different constraints, right? So what are the binding constraints? What are the slack constraints? And when we start looking at those constraints, there's some implications for analysis or management that should pop to mind immediately. So first of those, if a constraint is binding versus it being slack for analysis, well, if we were thinking about especially one of these simple or small problems like we do for class, what new activities, right, could be considered? Well, if we were thinking about adding activities to our corn and soybean problem, expanding on that front, one obvious place to look would be the slack resources. What resources are we not using in full And are there really efficient ways of using that slack resource, new activities that we could bring in? New capacity, okay? So as a manager, right, or as a decision maker, one of the things that we're always interested in is sort of a longer run solution, right? So the solution to one of these LP problems is almost always given current conditions. Well, business operates on not just putting out a plan for today, but a longer run plan that's going to change the capacity or the conditions that we operate under. And so the place to look for those are, what are the binding constraints, or what are the things that limit the returns? And so let's switch back to our spreadsheet and look at the solution. Sorry. Look at the solution that we have here. And first thing they tell us, or the first thing Solver told us, was this earns us 20,100. There's a temptation to look at that as a comparison to the cash constraint. I would just say don't, because the cash constraint here is being measured in kind of an odd way, right? We are saying this is cash on hand, or maybe you would think of it as a credit line, however you want to think about it. It's not like saying we made $100 profit in some ways, because we did not have a disposal activity for this cash. If this cash showed up as slack, the way this model is written, there's no way to account for the fact that this cash may have some value. So this cash, I always put this model together early in the semester to get people thinking about this. If we wanted to have a valuation for this cash, you would need a new activity that says, hold on to my cash, right? And that would say, only use the cash in activities if they can generate higher returns. And so we didn't do it that way. So we are implicitly saying that this cash is more of a available credit line, or sort of a resource to be used, but we have not turned it into a marketable or a profitable, no other activities for sort of investing this cash. The only ways we have to generate, because we wrote the profit equation up here in this way, the only way we have of turning this cash into profit or returns to the firm is via the corn and soybean activities, okay? And that is an important piece to think about when you look at the land constraint. So we said one of the ways, let me look at this again. Let me take you through the steps in order. So we have the objective, 20,100 in returns. We have the activity levels, 140 of corn, 130 of soybeans, okay? And so that's sort of the basic reporting on what do we do, right? What's our plan? The plan is right here. What's it worth? Right here. And what did we use? What did we use? What's the status of the resource availability on the farm? And that's what we have down here. So we have the left-hand side and the right-hand side that can be compared. And what we have is, using all of the cash, using all of the storage that's available, those are binding. So if we wanted to think about this going forward, this problem, and think about where should we invest, where could we generate new returns from expansion, it would be in these two constraints. So either new storage space investments could be valuable, because those are the things that are currently limit us to this level of profit. A bigger credit line, or a bigger sort of cash availability, or cash on hand to get the crop out, being reserved, would also allow us to expand operation. The one thing that doesn't is land. So we have 320 acres available to be planted. We only plant 270 because the bottlenecks, or the limits, are on these two constraints. So this gives us a real opportunity to think about the solution to this problem via this slack constraint. Okay, what's a good use of 50 acres? Well, obviously the first thing a farm operator or a farm manager might think about is, well, let's think about new crops. New crops would use that acreage. But a problem that arises there is if that new crop requires storage or cash, the cash on hand, then we're already at our limit there. So the only thing that might be done is if it uses less storage or less cash than the two crops we're planting, we might replace soybeans or corn acres with this new crop, with this third crop. And then if you keep thinking about it, this problem says right now, I mean, the inadequacy of this problem for our purposes, knowing what we know about farming, it's almost too simple, right? It's a good demonstration for us to learn from, but if we wanted to implement something here, at a minimum, we should say, if I have 50 acres of land and I'm not using it because I've run out of cash and storage to get crop onto the full 320, well, I should be thinking about, is there a rental market that I could send my extra 50 acres of land to? Could I be letting someone bid on these 50 acres? And the important part of this, something we'll come back to next module, is what's the right rental rate? What's the rental rate that would cause me to want to let someone else use my land? And the answer is pretty simple, because if somebody's willing to offer you money for 50 acres that you can't get anything on, the way this model is set up, the way we've solved it, there's 50 acres you just can't plant crop on because you're constrained by these other activities. As long as somebody's willing to give you positive money, right, and you could think of that as a net positive, right, so they're not destroying or eating into the productivity level of the land. As long as they're willing to give you a net positive return in terms of rent, they should be you should be able to rent it to them, and that should be an easy decision. And what we would do is we would expand this model out. I'm not going to actually do it, but we'd expand this, and we would just add a third activity up here that says rent land. Up here we would say Excel, choose the level of land to rent out. Here we would say, how much profit do we want? How much return or how much rental rate do we want per acre of land? We would add that in. Okay, I'm not going to go through all the steps to do that, but that's certainly something we'll deal with later. Okay, that gets us to the end of our discussion on Lab 1. I hope it's helpful for those who want a more detailed, more involved, more instruction-oriented lab experience. But for those of you, that I'll tend to let these run on and be a little bit longer and a little more detailed in terms of explanation. But realize that I do understand this is overlapping with your reading and with the handout that gives you the sort of step-by-step go on your own pace instructions. So that's why these are being termed optional videos. Okay, well, that's into this lab, and I'm going to move on to the next lab with a new video.